revision of unit load method, flexibility method procedure for frame analysis of frame 1, 2, and 3, and then assignments. Now, frames are analyzed with flexibility method due to, again, the three reasons we have. It is more systematic. You can find out the support reactions with this, and you can find out the internal axial shear and bending moment also in the indeterminate frames by using this method. Now, flexibility method for frame analysis. The force method of analysis can readily be employed to analyze the indeterminate frames. The basic steps in the analysis of indeterminate frames by force method are the same as that discussed in the analysis of indeterminate beams in the previous lessons. Under the action of external loads, the frames undergo axial and bending deformations. Since the axial rigidity of the members is much higher than the bending rigidity, the axial deformations are much smaller than the bending deformations and are normally not considered in the analysis. So axial deformations we will not be considering. Why? Because those are negligible. Only the bending deformations we will be considering here in this course. The compatibility equations for the frame are written with respect to bending deformations only. So only bending deformations will be involved to write these compatibility equations. Axial will be ignored, and again the reason is those are negligible. Again, prerequisites for analysis with flexibility method. It is necessary that students must have strong background of the following concepts before starting analysis with flexibility or any other matrix method. So again, you should be having enough concept of matrix algebra, must be able to find the statical indeterminacy and concept of deflection methods, and here now unit load method you need to know. So this week you need to take out time and refresh your minds about the unit load method. Already you did revision for the conjugate beam method for the analysis of beams. So now unit load method is coming. So we are going systematically now. Unit load method now, revision of unit load method for displacement. Kya tha wo? Let's discuss that one. This method is based on the principle of virtual work, most suitable to find the slope and deflection of primary structure when subjected to applied loads. Displacement due to external loads at any point I is given by delta I is equal to summation of I is equal to 1 to m. M is the number of members now. Mi, small mi divided by ei, and it's an integral actually. The moment diagram is going to change now, so we need to take the summation of the integrals of the product of these m's divided by ei. What is the capital M? This is now, these are the moment equations in the release structure when it is acted upon by the actual loads. And what is the small mi? When this basic determinant structure or release structure is acted upon by the unit loads corresponding to the redundant actions turn by turn. This is that small m. So we need to find out the product of these m's, take the integration over the applicable lengths divided by ei, and we sum up the effect of all the members. Then that way we can find out the deflection at a specific location. Now displacement at any point I due to unit load at j is given by, also called the flexibility coefficients. Agar aap flexibility coefficient मालूम करेंगे, so that will be mi and mj now. delta ij is equal to flexibility coefficient at I due to j. Now it will be equal to mi mj. Now this is the application of the unit loads now corresponding to the displacement, corresponding to the redundant actions now. So it will be the product of the small m's now, and m is coming from the application of the unit loads now, not the real loads. In the above equation, m are the equations of bending moment in primary structures subjected to external loads, and small m are the equations of bending moment subjected to unit loads. So here you can see the definition of the m's. Analysis procedure for the frames. The following steps should be followed to analyze a statically indeterminate frame using flexibility method. Start with finding the degree of statical indeterminacy. Now identify the redundants and obtain basic determinant structure. Also compute the DRS values. So number of redundants will be equal to the degree of statical indeterminacy. Let's assume number of redundants is equal to 2. Just to understand the procedure, 2 degrees problem we are considering. Note, for choosing the redundant actions, there may be more than one possible options, but choose that one as redundant, which makes the calculations handy. DRS is initial support, rotation, and settlement corresponding to redundant location. So these now parameters and these things are the same as we did in case of the beams. Step number 2, now analyze the basic determinant of primary structure under the following loadings now. First, what we do, we analyze the basic determinant structure when acted upon by the external loads and write the equations of bending moment capital M for different segments. Remember, these steps are nothing, we don't have anything new now here. This is the same which you did in the 4th semester for finding out the displacements at various points in case of the frames. Already virtual work method you have discussed. The point of interest where you are investigating the deflection, where we are applying a virtual load of unit intensity. This is the same thing. Step number 2 now, analyze the basic determinant structure when acted upon by the unit load at redundant location 1 and write the equation of bending moment M1 for different segments. Then analyze the basic determinant structure when acted upon by the unit load at redundant location 2 and write the equation of bending moment M2 for different segments. So for 2 degrees problem here up to step number 3 you will go. If you have more now degree of indeterminacy, so then and so on, if redundants are more than 2, so you will have to continue till the degree of indeterminacy. Now note, to write an equation, take a section in each segment of loading and then write bending moment equation with proper sign convention. Remember at a section how to write the bending moment equation, that is important. Now you need to now refresh and learn that thing also, how we write equation at a section. Then step number 3, develop bending moment equation table. You need to write the bending moment equation. This table, bending moment equation table, will consist of following items which will make the calculations work easy. First column, you will be showing the segment, then origin, limits, that is length of the segment where the equation is going to be applicable, moment of inertia for that particular section, that capital M, which will be coming from the actual loads application, small m from the application of the unit load corresponding to AR1, then M2 corresponding to AR2 now. Now here we are writing the segment now. So origin, let's say from A to B or B to A, where you are taking your origin and how you are going to progress. Limits. Now, starting point and ending point where this equation is going to be applicable. I, whether it is I2, I1.5, I, so you need to value. Similarly for the other segment BC also you need to do this thing. Moment equation, if you take the A, let's say A is your origin, so at A will be becoming 0. If B is origin, so B will become your 0 starting point. And you will have to write the plus and minus sign accordingly. So moment equation accordingly you will have to write. When it is under the actual load, then under the AR1, under the AR2, and similarly for segment BC also. Step number 4 now, here you need to find out, already you have the capital M value, you have the small m value, so that way you can find out your DRL1 value. DRL1 again, it is the displacement corresponding to AR1. So it will be the summation of the members, all members effect, integral of capital M small m divided by EI dx now. And DRL2 will become capital M times M2 now, DRL2 corresponding to 2. So this will become M2 now divided by EI dx. This way we compute the DRL matrix. So it will be involving the writing the moment equations, then finding out the product of these moments, then integration, putting the limits, and then the summation of all these effects. So this way you can compute the DRL1 and DRL2. Now what will be F11? Now the same now configuration we will be using. F11 will become equal to M1 small m1 times small m1 divided by EI dx. What will be F21, which will be equal to F12, there will become M1 times M2 divided by EI dx. And what will be F22 now? F22 will become product of M2s now, M2 times M2 divided by EI dx. And already you can grab your all these values from the table which were in the previous slide. So here now you can see F11, combination of the product of small m1s, F22, the product of the small m2s, again summation and all these things you can see, and F12 is equal to F21, it will be the summation of m12s. Okay. And this way you make the flexibility coefficient matrix. Now going towards the compatibility equation and principle of superposition we are using. So again, the same configuration we have. AR is equal to F inverse DRS minus DRL. Here again, the member induction. So the same way, AM is equal to AML plus AMR times AR. So we can find out the member inductions. And after that, we can draw the shear force and bending moment diagrams. So we start with a problem now. Problem number 1, which is on the frames now. Now, it's 1 bay 1 story frame now. A, B, starting from the left side now. The bottom support left bottom, it is support A. Joint B, above this, to the right, we have joint C. And at the bottom again, to the bottom right, we have C or D, joint D, where we have a hinge support now. At B, rightward directed, we have 5 kip load. BC, the beam member, we have 2 kip per foot UDL. Its I is 2I, and the left column AB, it is having I, and right column CD, it is having I. The horizontal distance is 30 feet and the vertical is 15 feet. This is the geometry, the geometrical properties and the loading on the framing. Now this frame, if you see, it is 2 degrees indeterminate. So statical indeterminacy, here we have established 2 degrees. So 2 redundant actions should be chosen, and again choose the redundants in a way so that you can easily solve this problem. Now we go to the next problem, next slide I mean. Yeah, you have question? Is there any
No, sir.
is there any question?
No, sir. I'll prove.
Okay. Okay, so let's now go there. Now at D now we are assuming AR1 upward reaction as our redundant action and then rightward AR2. Again, remember you have the choice to reverse these directions, right? But here I'm assuming initially these, so these are arbitrary directions now. Vertical reaction at D and horizontal reaction at D. Now, upward and rightward, I'm assuming my positive direction. What will happen if these directions are not okay? So I'll get the negative value and I can reverse the directions then. So now, if we remove these AR1 and AR2s, what will happen now? This structure will become a release structure now, which is a basic determinant structure. So identify the redundants and obtain BDS, also compute DRS values. So AR is equal to AR1, AR2 unknowns, and DRS1, we don't have any precondition here. So DRS1 and DRS2, these are equal to 0 and 0. So vertical and horizontal reaction at D are chosen as redundant actions. Now next, this is now your release structure. You see here A, B, C, D, D, the redundant actions are removed. At A, we have a fixed support. So this is a determinate frame now. Now, to write the capital M values, what we will do, we will put this under the actual loads now. So here now, step number 2 is starting, analyze the basic determinate primary structure under the following load conditions now. First, we need to find out the capital M values, and for that, we need to analyze this basic determinant structure acted upon by the external loads and write the equations of bending capital M for different segments. Then, analyze the basic determinant structure when acted upon by the unit load at redundant location 1 and write the equation of bending moment M1, small m1 for different segments. And then analyze the basic determinant structure when acted upon by the unit load at redundant location 2 and write the equations of bending moment M2 for different segments. So next now, this sign convention is also important. Here now, if you see, this is the same basic determinant structure. At A, we see the fixed support. This was a rated joint B. So we have split this into 2 now. Still, it will transfer its forces. Actions, I mean, it can transfer the moment as well as it can transfer the shear and axial force also. C, we have opened the joint only. Rest, it is the same. And D. Now, if we start analyzing from the right-hand side, on the right-hand side, we don't have any load. So here, the axial, you see the vertical line at D, that is 0. The shear horizontal line, that is 0. And the moment, that is also equal to 0. We need to keep this member in equilibrium. So nothing in the vertical direction at joint B, so it means in between we don't have any load, so nothing is going to be balanced at joint C. So this joint C vertical, it is becoming, which is axial force, this is becoming 0. Shear, it is 0, and bending moment is also 0. Now at joint C should be in equilibrium. So whatever we have horizontal here, that should be here also. So 0 horizontal at the right side, so at the left side also 0 horizontal. 0 vertical at C at the right, so 0 at here also. And then bending moment 0, so 0 bending moment here also. So this joint C is also in equilibrium. Now let's do analysis of this member BC, the horizontal member, which is carrying a load of 2 kg per foot. Now, in analyzing, we need to consider the support conditions now. One option of this is now this 2 kg, half of this load should be coming to joint C and half of this should be coming joint B now. But we cannot carry this half of load to joint C. What is the problem now? That's 2 times 30 divided by 2, which is 30. 30 keep here we are putting in the vertical direction. Then it has to be in equilibrium to the right of this joint C. So if it is upward here, it will become downward. So how we are going to balance this at joint G now, or D now, because at D we don't have any support. So it means this 2 kip per foot, it cannot travel to the right where we have joint C. It has to be balanced by B only. So 2 times 30, which is 60. So 60, this total load is going to be balanced by B. And from B, it can travel to this joint B, and from B, it can travel towards the support. So vertically now, this member BC, it is in equilibrium. 60 here and 60 in the downward, so 60 in the upward direction. Horizontal. If this horizontal is 0, here the horizontal is 0, so horizontally also it is in equilibrium. But now the problem is when 2 times 30, we are getting here an equivalent pointed load now, which is 60. And it is having a moment arm also, which is 30 divided by 2, 15 means. So 15, this is 2 times 30 is 60, and 60 times 15. So we have 900 now. So that 900 moment, that has to be balanced by this rigid joint. Now we cannot take this moment here, because from here it will come to joint C, and from joint C, then we don't have the capability at D to transfer it. So now at joint B, all the member and actions are calculated. The vertical reaction is 60. Horizontal is 0, and the moment, it is counterclockwise 900, which is coming from 2 times 30 divided by 2. Now this whole member is in equilibrium. All the boundary conditions and everything is met. Now joint D has to be in equilibrium now. So here 0, so 0 load is transferred here. Internally 0 load is transferred here, but this 5 kip, it is externally applied. Why not we are not bringing this to this horizontal member? Because if we bring it to this horizontal member, then it has to be supported by this C. From C it will come to the vertical member, but then there is nothing a D to support it. So it means that 5, it cannot travel towards the right by adopting this BCD path. It has to adopt this BA part now. 60 at B, it was upward, so here 60 in the downward, so joint is in equilibrium with respect to the vertical loads. Horizontal is 0, so 0 is transferred here. 900 is counterclockwise, so 900 clockwise now. This joint B is now equilibrium conditions, those are met. Now taking AB, so AB now, the vertical reaction at A, it will be now putting in equilibrium, keeping in equilibrium this 60 kip. So 60 in downward, so this 60 is in the upward direction. 5 kip, it is rightward directed, so 5 kip leftward directed, so horizontally this member is in equilibrium. Now moment, when we have 900 in the clockwise direction, and 5 times this 15, which is also causing clockwise, so 5 times 15 is 75. So 75 plus 900, 975, it is now balanced by this 975 here. So this member also, this is analyzed and this is in equilibrium. Now, based on this, now we have 3 members. We can write the moment equations now. And the moment equations we write from an end where we can write these equations simply, because you need to keep in mind that it will be getting, now it will be having a product with the small m values also. So the product of 2 components is much more now hard as compared to the product of 1 element. I mean 2 multiplied by 3, if we do 6, but if I ask you that now you do 975 plus 5x times a plus b, so it is becoming more complicated. So you choose origin in a way which is resulting in a simple product. Here I can give you the example BC if we take. So if we take the BC, this vertical is 0. So here the moment equation will be simply 2 times x squared divided by 2. Right? This will be 2 times x squared divided by 2. But if we write from B to C, if we take the B as origin, so this will become equal to 60 times x minus 900 minus 2 times x squared divided by 2. So it will be having 3 components. Now from here it is having 1 component. So it is easier to take this C as origin instead of this B as origin. Now how this moment equation MB is written? Here the origin is taken as A. So we have a moment of 975. Why in this is causing negative? Why? Our sign convention is the outer, if we have tension on the outer fiber, that will be negative value, negative moment. If moment is causing tension on the outer fiber, what is the outer fiber now? I consider myself standing here inside the frame now. So what is coming away, that is my outer. And what is the nearest one, the nearest face, that is coming my inner one. Now, if we start bending this in this direction, so the outer will become tension, so minus 75. And then we have plus 5 times x now also. Why plus? Because this 5 times x, it is causing compression in the outer fiber. So this is now the moment equation for member AB. Which one? Capital M value now we are generating. We already discussed this MBC. How the MBC is coming, the origin was C now. So this is minus. Why? Because when it starts bending in this clockwise here, it will cause tension in the outer fiber. So minus is coming from there, and it is 2 times x divided by 2. So 2 will cancel, and we are left only with minus x square. So this is minus MCB or MBC is equal to minus x square. Now here you see here also x is starting, C is 0 and it is going towards the left. This is x starting 0 and it is going in the upward direction. For CD member, we take the origin at D now. So D here, we don't have any now, this horizontal, which can cause the moment now. So 0 times x is 0. So MCD is equal to 0, but the origin is D. Remember, once you have fixed the origin now for calculating the capital M values, now you don't have the flexibility to change the origin in case of calculating the small m values. You will have to follow the same origins now. That is must. You don't have any freedom now to change the origin. So next now we go to the M1 values. M1 values now you see here at D corresponding to AR1, we have applied in the same direction a unit action now. And we analyze each joint and each member now. One cap here, we start from member CD now. One cap in the upward direction at D. So at C we have one cap in the downward. Horizontal at D0, horizontal here also, nothing is going to be balanced in the horizontal direction. Moment, this axial force is not causing any moment. So at D, moment is 0, MC is also equal to 0. This member is completely analyzed. Member now joint C, we need to put in equilibrium. So one cap to the right of joint C, it is in the downward, to the left, it is in the upward direction. So in the upward direction, it is in equilibrium. Horizontal here, it is 0. So here also it is 0. Moment 0. So 0 moment is transferred. Now let's analyze member BC now. One in the upward direction. So at B joint, it should be in the downward direction. Horizontal 0, so horizontal 0. Now if we put this one cap in upward, one cap in downward, it is causing a couple. So it will cause a spinning effect now. We need to stop this spinning now so we can balance this couple by a moment now. Moment here we cannot apply. Why? Because then it has to be resisted here and transferred here to the free end, which does not have the capability to resist. So the only point is this joint B now, where it can be resisted. And how much? The couple is now, the couple moment is 1 times 30, and it was causing couple in the counterclockwise direction. So it has to be resisted by a moment of 30 kip in the clockwise direction. So here we show the 30 kip moment. Now, joint B has to be in equilibrium, so 1 kip in the downward direction, so 1 kip in the upward direction. 0 horizontal, so 0 horizontal. 30 clockwise, 30 kip with counterclockwise, so joint B is in equilibrium. We need to keep now this AB member in equilibrium, so 1 kip in the upward direction, so 1 kip in the downward direction at A. Horizontal 0, horizontal is 0. 30, it is counterclockwise, so 30 clockwise here at joint B. So joint B also analyzed and is in equilibrium. Origins already we fixed. For member AB it was A, for member BC it was C, and for member CD it was D. Let's start writing the moment equation. 30 kip fit, it is causing compression in the outer fiber. So M1 for member AB, it is 30 plus. Why? Because it is causing compression. 0 times X, it is giving you 0. Member BC starting from C now, 1 times X, it is causing compression now. So positive, and 1 times X is X. So M1 CB, it is X. And then member CD starting from D now, we have 0 times X, and 1, it is already axial. So this is causing 0 times X. So 0 M1 CD, we have this 0. Now, ask me if you have any question till this point.
क्लियर है सर।
अच्छा ठीक है, ये ऑलरेडी आपका आ रहा है, वही 4th सेमेस्टर से ना, ऑलरेडी ये चीजें आपने की हुई है. सो यू नीड टू गो बैक एंड पुल आउट दोज नोट्स और इन चीजों को आप रिवाइज कर लें. Next now, corresponding to आप देख लें, AR2 was rightward directed 1 kip. So rightward directed 1 kip, we are applying at D now. Because of this, we are analyzing the whole members and the whole joints जो है ना वो analyze कर रहे हैं. CD को कैसे analyze करेंगे? This was 1 kip rightward directed, so at C it is 1 kip leftward directed. Horizontally, the members are in equilibrium now. Vertical 0 here, so 0 we have here also. Now this 1 kip and 1 kip, it is causing a couple now. So 1 times 15, it is causing a counterclockwise. So by a clockwise movement, we need to balance it. So 15 kip for this moment I'm putting at C now. This joint C should be in equilibrium. So here you can see 1 kip leftward directed, so 1 kip rightward directed. 15 kip foot clockwise, so 15 kip foot, it is counterclockwise. 0 upward, so 0 here. So you can switch C. So this joint C is in equilibrium. BC now we need to analyze. 1 kip rightward, so 1 kip leftward. Horizontally member is in equilibrium. 0, 0 in equilibrium. 15 kip fit, so it can be resisted here. 15 kip fit. Moment is also so in equilibrium. Joint B, to put this in equilibrium now, 0, 0, 15 clockwise, 15 counterclockwise, 1 leftward, 1 rightward. So joint B. And similarly now here, we need to now transfer this to joint A now. So 0, 0 horizontal, it was rightward, this is leftward, this is counterclockwise. And here now, why 0? Because 1 times 15, it is causing 1 times 15, 15 clockwise and 15 counterclockwise. So 15 minus 15, it is coming 0. So that is why here we are showing this 0. To write now the moment equations for AB, again origin is A now, so 1 times 15, 1 times X, not 15, 1 times X now, it is varying, so 1 times X we are taking, so X is here. For BC, we have 0 times X, so that is 0, but here it is causing compression, 15 kip fit, so moment is coming 15 now. And here it is causing 1 times X. So plus X here, we are writing this one. Now we can complete the bending moment equation table. Segment AB, BC, and CD we were having. Origin for AB we took A, for BC we took C, and for CD we took D as origin. Limits, this equation for AB, it will be applicable from 0 to 15. This is 0 to 30, and from here 0 to 15. Moment of inertia for AB it was I, for BC it was 2I, and for CD it was I. Now M value is already 5x minus 975. This was minus x square. This is 0. M1 values 30x and 0. And M2 values it was x, 15 and x. Let's verify this small m. For member AB 30x and 0. 30x and 0. So let's go for 30x and 0. You see here 30x and 0. From here we are filling this row. Here this is done now. Simply now rest of the calculations, it will be coming out of these numbers. Now it will be the product of different combinations. So now we want to find out DRL. So DRL1 will be equal to M1 or EIDX. So DRL1 for member 1, if you see, it was from 0 to 15. 5x minus 975, this was the capital M value. The small m1 was D30 dx. Then member 2 combination, it was minus x square for capital M. M1 was x divided by f. From where this 2 is coming, this was actually divided by EI. So I was 2I actually. So EI we took common now. Plus 0. Member 3, if we see, member 3, why it is 0? Member 3 is here. So 0 times 0, it was coming 0. So that is why we are writing there 0. Minus x square x, and this is this. So we are just simply finding out. Now find out the product, put the limits in, and we are getting this number. DRL1 is equal to minus 523, 125 divided by EI. DRL2 now will become the product of capital M times M2 divided by EI dx. So here we see M2 is the same, 0 to 15 for member 1, 5x minus 975 times, how much is M2? This is x now. Member 2 is coming here. Again, this is because of the 2i. And here it is 0 times the M2 values, so it is giving 0, so DRL2. We found DRL1, DRL2, and we record those values here. Next, we come to the generation of the flexibility coefficient matrix. And it is coming now the product of the small m1s now. So here you see now 30 times 30. Let's go back to the table now, M1 and M1 for member 1. So let's go there, member AB here, this will look from here, 30 times 30. This will be x times x, this will be 0 times 0, and the limits also you can see here. So this is how this matters, 30 times x, and this is 0 for the CD member. Now you need to practice these, finding out the products, taking the integrals and putting the limits in simple calculations, but it will involve a lot of calculations. F11 is calculated at 18,000 over EI. Next, we go to F22, which will be the product of M2s now. So here now, F12 is equal to F21, and here it is coming now. Now I don't know, okay, this is M2, but here F12 is equal to F21, we are finding out. So 30 times x dx, 15 times x dx, and this is 0. So F12 is equal to F21, actually this is the equation now. Then F22, it is x times x, 15 times 15, and x times x. So F22 is coming, it is this value. The flexibility coefficient matrix is complete now. Rest, we need to apply now the compatibility equation and the principle of superposition. we plug in the values and find out. So AR1, it is coming 32.02. And AR2, we selected this rightward directed, but now this negative is showing that we need to reverse the direction. So it means it is leftward directed. So here now we put this instead of the AR1 and AR2s. 32.05 you see in the upward direction and 7.92. Now from equilibrium, very easily you can find out that here what will be the reaction. It will be 2 times 60 minus 32. So it will be coming something 28.8595 or whatever. And you can find out the horizontal also. It will be rightward directed 2.97. Now, if you want to find out the member inductions by using the matrix notation, very easily you can find out. How? Let's deal with that. This is how we find out rest of these values. You see here by using the equilibrium. So rightward directed, this 5 plus 2.95 should be equal to this one, and the summation of so 27.95 plus 32, which is giving you 60. This one you can find out the moment also. Now let's find out the member inductions now by using the matrix approach. Again, if you understood the beam method, it should be easy to find out these member inductions. Now, initially we need to fix some positive directions, and I prefer to select upward, rightward, and clockwise as my positive direction. Here you see at A, AM1 upward, AM2 rightward, and AM3 clockwise. Similarly at B, AM5 rightward, AM4 upward, and AM6 rightward. So those initially I take because I have the freedom here to select anyone as my positive direction. But the thing is, when you start making calculations, you will be ahead 2-3 pages. So you don't need to flip again and again and see which one is my positive direction. Already you have determined and fixed your positive direction. So you can compare with those one in order to select the positive AMLs and AMR values. All these 6 member inductions, 3 at each end, we declare them as our unknown member inductions, AM1, 2, 3, 4, 5, and 6. From where we are going to get the AML values now? From the same where we found the capital M values. AMR from where we found the small m values, and AR already we have. So now here you can see the AML 1, 2, 3. You already fixed the reference, so accordingly you will be picking your values now. Already we analyzed this under the actual loads from where we wrote the capital M values. So here now you see what is AML1. Here you see it is 60. So here we record this 60. AML2 is how much? It is rightward positive direction. So it is in the opposite direction. So this is becoming -5. So here we write the -5. AML3, it was clockwise. Here it is counterclockwise. So this is becoming -975. Then AML4 upward. 60 is in downward direction, opposite to this one. So again, it is -60. This is in the same direction, so +5, and 900 in the same direction, so this is 900. From where these AML1, actually these are corresponding to the AM values. AM, there you have the provision to select your positive direction. Any question? Hello? Huh?
No, sir.
It is clear now, right? Because this
No.
AB, this is just like your beam now, which is in the vertical direction. Member inductions already आपको पता है कि AM को हम कैसे लेते हैं, फिर AML को कहाँ से उठाएंगे और उनके directions हम कैसे लेंगे. अब यही
Yes,
ए
sir.
बी
Clear, sir.
मेंबर, यही ए बी मेंबर लेके हम इनके ए एम आर मालूम करेंगे। तो वो स्मॉल m1 और m2 वैल्यूज तो है ऑलरेडी आपके पास, वहां से आप अपना फर्स्ट कॉलम ऑफ द AMR मैट्रिक्स और सेकंड कॉलम ऑफ द AMR मैट्रिक्स आप मालूम करेंगे। सो हियर नाउ AMR 11 आप देख रहे हैं, ये वही है जो ए बी पे एप्लीकेशन ऑफ द AR1 के करस्पॉन्डिंग जो आ रहा था उसी से। अब AMR 11 क्या होगा, ये -1 होगा, तो यहाँ पे -1 हमने लगा लिया। AMR 21 0, तो 0 हो गया। AMR 31 कितना आ रहा है, 31 इट इज इन द सेम, सो +30, तो +30 हो गया। 4-1 कितना आ रहा है, 5-1 कितना आ रहा है, 6-1, इसी को देख लें आप, इसके करस्पॉन्डिंग वही वैल्यूज आप लगा लें। -30 क्यों आ रहा है, क्योंकि यहाँ पे क्लॉकवाइज था, यहाँ पे काउंटर क्लॉकवाइज हो गया। फर्स्ट कॉलम आपका कंप्लीट हो गया। सेकंड कॉलम के लिए क्या करेंगे, M2 की वैल्यूज जहां से आपकी आ रही थी, तो वही मेंबर ए बी की वैल्यूज लेंगे। तो ये देखें आप, ये 0 हो गया, तो 0 लग गया यहाँ पे। आप ये कर्सर देख सकते हैं व्हेन आई एम मूविंग द कर्सर।
Yes, sir.
Yes, sir.
अच्छा ठीक है। सो दिस इज 0 हो गया। यहाँ पे AMR 22 देख ले, ये -1 हो
Yes,
जाएगा।
sir.
ये कितना है, ये 0 हो जाएगा, तो 0 लगा रहे हैं। यहाँ पे देख ले 0 हो गया, ये 1 हो गया, और ये -15, तो ये वैल्यूज यहाँ पे आ गई। इसके बाद हम क्या करते हैं, वी गो एंड राइट, वी कंप्लीट दी AMR मैट्रिक्स। तो AMR आपका मैट्रिक्स कंप्लीट हो गया। अब जब आप सवाल हल करेंगे, यू डोंट नीड टू राइट दिस AMR 1 1 2 1 3 1, स्ट्रेट अवे यू राइट दिस एंड मेक दिस मैट्रिक्स। Now next we write this equation now. AML values भी है आपके पास, AMR values भी है, AR values भी है आपके पास, so you can find out all the member and actions। ये देख रहे हैं with the original science, ये आपके सारे member and actions हो गए। After this we come and we write this on the member। ये देखें members पे हो गए, ये 27.95 आ गया, ऑलरेडी है भी ये वैल्यू हमारे पास, वहां से इक्विलिब्रियम इक्वेशन से। ये देखें 2.95 आ गया, 13 पॉइंट। ये मेंबर अब आपका पूरा एनालाइज हो गया। इन बिटवीन वी डोंट हैव एनी लोड नाउ, एक्सटर्नल लोड। इसके बाद क्या है, इसकी मदद से हम शेयर फोर्स डायग्राम ड्रा कर लेते हैं, और इन मोमेंट वैल्यूज की वजह से हम मोमेंट डायग्राम ड्रा कर लेते हैं। दिस इज योर नाउ रेगुलर थिंग नाउ। तो ये मेंबर ए बी का पूरा शेयर फोर्स और बेंडिंग मोमेंट डायग्राम आपका आ गया, इनकी मेंबर एंड एक्शंस भी आ गई। अब यही वैल्यूज आपकी ट्रांसफर होगी वहां पे बीसी पे, लेकिन बीसी को आप अगर फर्ज करें इंडिविजुअली आप एनालाइज करना चाहते हैं तो कैसे करेंगे। ये आपका बीसी मेंबर होगा, अगेन अपवर्ड, राइटवर्ड एंड क्लॉकवाइज वी आर टेकिंग देम एज पॉजिटिव। तो AM 1 2 3 4 5 6 हो गए। इसके बाद आके हम क्या करते हैं, वी स्टार्ट नाउ AML वैल्यूज करेंगे। तो ये AML वैल्यूज करस्पॉन्डिंग हो गई। अब ये एनालिसिस से आपकी वैल्यू ऑलरेडी जो आपने कैपिटल M का किया हुआ था वो वैल्यूज है आपके पास। अब AML आपका क्या है, 60 आ रहा है, AML2 कितना 0 आ रहा है, AML3 कितना है -900। तो यहाँ पे आप देख रहे हैं 60 0 -900। AML4 5 और 6 आपके सारे 0 आ रहे हैं, तो सारे 0 रिकॉर्ड हो गए। अब फर्स्ट कॉलम ऑफ द स्टिफ दिस फ्लेक्सिबिलिटी कोएफिशिएंट मैट्रिक्स, इस केस में जो आपका AMR होगा वो आपका वही से आएगा जहां से आपने M1 स्मॉल m1 की वैल्यूज लिखी हुई थी। तो ये वही, ये क्या है, AMR 11 -1 हो गया, तो -1 यहाँ पे लिख लो, ये 0 और ये 30 हो गया। यहाँ पे ये +1 0 एंड 0, ये सारी वैल्यू आपकी फर्स्ट कॉलम में आ गई। अब M2 की तरफ जाए और ये वैल्यूज आप, ये कॉलम आप कंप्लीट कर लें। ये उसकी तरफ हम चले गए, ये वैल्यूज थी, तो यहाँ से उठाए 0 -1 एंड 15, सो 0 -1 15 हो गया। यहाँ पे 0 1 एंड दिस इज -15, तो 0 1 -15 यहाँ पे कंप्लीट हो गया। इसके बाद इक्वेशन सॉल्व कर लें, इक्वेशन और ये सारी मेंबर एंड एक्शंस, ये अगर आप मैच कर लेना तो वही ए बी के लिए जो ए बी के लिए बी पे जो आपने मालूम की ये उसके अपोजिट साइन में होगी, इन द अपोजिट डायरेक्शन। व्हाई दैट वाज 2.59, ये 7.59 क्यों हो रहा है? बिकॉज द एक्सटर्नल 5 किप लोड इज आल्सो एडिंग हियर। सो हियर नाउ वी राइट दिस, यहाँ पे हम लिख लेते हैं वैल्यूज। ये वैल्यूज हो गई सारी। अब इसके बाद हम क्या कर सकते हैं? वी कैन ड्रा इट्स शेयर फोर्स एंड बेंडिंग मोमेंट डायग्राम। ये उस पे ये वैल्यूज लग गई, ये इसका शेयर फोर्स डायग्राम हो गया। यूडीएल इज ऑलरेडी देयर। अगर मेंबर फोर्सेस भी है आपके पास, मेंबर एंड एक्शंस भी है आपके पास, और एक्सटर्नल लोड्स भी है, तो बड़े आसानी से आप शेयर फोर्स और बेंडिंग मोमेंट डायग्राम ड्रा कर सकते हैं। बीसी मेंबर भी हो गया। अब क्या करते हैं हम? मेंबर सीडी की तरफ जाते हैं, विच वाज द राइट साइड मेंबर। उसी की तरह वही एम 1 2 3 आपका चॉइस है कि आप हॉरिजॉन्टल पहले लेते हैं, वर्टिकल पहले लेते हैं, जो भी है, लेकिन वही वैल्यूज फिर आप ऑनवर्ड्स आप फॉलो करेंगे। ये एम 1 2 3 4 5 6 तक हो गया। एम एल वैल्यूज आप मालूम कर ले, वो ऑलरेडी है कैपिटल एम वैल्यूज से। फिर आप एम आर, तो स्मॉल एम 1 से अपना पहला कॉलम आप कंप्लीट कर लें, और दूसरा जो है ना दूसरे से कंप्लीट कर लें एम 2 से। देन ये मेंबर एंड एक्शंस आ गई, वी ड्रॉ देम। और इससे हम क्या करते हैं? शेयर फोर्स बेंडिंग मोमेंट। ये देखें यहाँ पे आपका हिंज सपोर्ट था, तो मोमेंट आपका 0 आ रहा है यहाँ पे। इसके बाद अगर आप कहते हैं ये इंडिविजुअली हर एक मेंबर के लिए हो गया, इसको आप कंबाइन भी कर सकते हैं, तो ये आपका कंबाइंड शेयर फोर्स डायग्राम हो गया, और ये कंबाइंड बेंडिंग मोमेंट डायग्राम हो गया। Now with this, I'll give you this week to revise your unit load method, how we analyze a joint, how we analyze a member, आप इक्विलिब्रियम में कैसे रखते हैं इसको, and you go quickly, not quickly, but in detail for this specific problem. Frame problem number 1. आप इन चीजों को आप रिवाइज, होप इसको आप स्टडी कर लें, and rest of the problems inshallah we will do coming week in the next lecture, so that you can get time and you can absorb them properly. Now you can turn on your mics, and if you have any question you can ask me. Otherwise we are done for today's class.
सर
Yes.
सर ये जो हम पिछले